October 10th, 2021. October as a whole in 2021 for Oklahoma and most of the Southern Plains was extremely unprecedented and odd because not only were there a bunch of tornadoes, but a whole ice storm as well, and that came pretty much out of nowhere. And a lot of records were broken that month of that year. So let's go ahead and go over it briefly. In this video, I will break it down. Mostly the October 10th, 2021 Oklahoma tornado outbreak, but also a bit of the ice storm later on in the year, along with maybe a personal story of mine from this event. To start off, I do want to go ahead and go over the very inactive spring, or go over the year as a whole. To start, January had 4 tornadoes, which alone was kind of weird, not actually record breaking. If I remember correctly, there was another year where there was more tornadoes in January, but per usual, none in February. But spring begins in March, and this is roughly when we start to see more activity. Obviously, March had 3 tornadoes, well below average. April, only 5 tornadoes, which is again well below average. And May, we had 11, and once again, well below average. Usually, we average quite a bit for the months of April and May, so this is very unusual. June and July both went relatively below average as well at 1 apiece. So there obviously clearly wasn't much tornadoes in the first place. Until you look at October over here, 34 tornadoes. 34, which is just insane. That is how many tornadoes occurred in a month, most of them from the October 10th event in central Oklahoma. And here's a big list of all the tornadoes, and the only significant tornado happened in Cato County, south of Anadarko, which we'll go over here in a moment. To continue on here, the National Weather Service released this level 4 moderate risk for obviously central Oklahoma. Oh, wait, hang on. There we go. Here, it was a data map for Sunday, October 10th, 2021. And right off the bat, you can clearly see a cold front stretching down through the plains here. See if I can get a good look, and I can. And you can see that dry line stretching down there from southwest Oklahoma and western Texas. And that is about where we did see that lift occur, was about here. This is roughly where those storms started, there in southwest Oklahoma and far northwest Texas. And again, this is when things get pretty bad, is when you have a setup like this one, which I'll get to here in just a moment. The Storm Prediction Center released this map, and back then I wasn't too much into this kind of stuff like I am now in the past couple years. But something I do want to mention is just how strong this low pressure system was and its exact location. And it was obviously creating a lot of pulling up a lot of moisture from the Gulf of Mexico, and it created a very unstable atmosphere. But something I want to mention first is this low pressure system had a negative tilt, which brought all the moisture back north from Texas. This moisture, coupled with the high temperatures, caused extremely unstable air, especially across Oklahoma. This, combined with high levels of shear running 40 to 50, even over 50 knots in some areas, did create a prime environment for tornadoes, which is exactly why the Storm Prediction Center would later issue a level 4 moderate risk across Oklahoma. And let's go ahead and check this moderate risk out here. And It did unfortunately include Oklahoma City, and luckily most of it was suspected to be a little further south, but that unfortunately wouldn't quite be the truth. And something else was there was another low pressure system up here that was going to bring some severe weather up here in the along the Great Lakes, Northwest Great Lakes area, and something else as the tornado risk. It was very high at a 15% hatched risk. Again, that did include Oklahoma City. And usually when you see risks like this, it could mean two things: multiple, and I mean multiple tornadoes. I'm talking like possibly up to 2 dozen or greater, and unfortunately, long track violent tornadoes. But for this specific event, a lot of tornadoes were expected, including a couple long track violent tornadoes. And again, that did include Oklahoma City, Norman, and Midwest City, Moore, Oklahoma. Pretty much all of Oklahoma City and South. And something else was the wind outlook, because as this cold front, it did take a more linear shape, so it would eventually press down these storms into a linear storm mode or a line, and that would create much better conditions for brief, weak tornadoes and damaging winds up to 80 miles per hour. And the hail risk was primarily when the storms were isolated, because they started out isolated, and then as they continued moving east, they would get stronger as they moved into a more unstable, warm environment, along with remaining mostly isolated up until that linear point. And here the Storm Prediction Center does mention bulk shear at around 50 plus knots, and the potential for a couple long track supercells to evolve and track east northeast through Oklahoma. And luckily, that didn't exactly happen. But it was definitely very scary for a lot of people, without a doubt. And let's go ahead and go to this map here. And right off the bat, you can probably see like two different low pressure systems. This one to the north now is bringing the severe weather up here in the Northwest Great Lakes region, and a much stronger one to the southwest. And you can't really see it there. Hang on. Let me go ahead and switch to blue. Outs. Absolutely not. I am sorry. What about black? Okay, you can see black just fine. And out here, you can clearly see that tilt to it, and it was ejecting into the plains. And again, it was dragging up a lot of moisture from the Gulf, and this helped create that very unstable environment. And this is probably one of the strongest systems I've ever seen in fall for a fall weather outbreak. And let's go ahead and push up the time just a little bit here. That's more than a little bit, but pretty quickly you may see that there was actually another system behind it as well. And if I do remember correctly, this did swing in at around October 12th and did bring more severe storms across the southern plains. But we are focused on this storm system. You can kind of see obviously where it went from. It went from around the Four Corners region and ejected kind of in a curve, really. You'll see it on radar here in a moment. But really, what caught my eye was how it ejected and where its path was. It went right over central Oklahoma, and it created an almost hurricane-like effect. And the positioning of it also gave the storms a lot of a lift down here in northwest Texas and southwestern Oklahoma. And that created a lot of shear as well. Very, very unstable environment, and even kind of reminds me of the May 20th, 2013 EF5 tornado, the way that storm formed. And as I could progress this here, you may pretty quickly see where that cold front was. You can see some kind of showers and possibly even migratory birds, because there was just so many at once. And there was another line that I noticed that stretched out here. Kind of weird to see But going on into later in the day, you can really see where that cold front was. Because the closer it got to Oklahoma in that unstable environment, it started creating a whole bunch of showers and thunderstorms up there in the Oklahoma, Texas panhandles, and southwestern southern Kansas. And behind that cold front was freezing temperatures, actually. So you had a pretty clean cut of, like, I'd say 30-degree temperatures and 80-degree temperatures. It was created a very, very unstable environment. It wasn't really that lopsided as I kind of portrayed it there, but it still was, unfortunately, still a very big difference, just as a whole. And that created an even more unstable environment, especially along that cold front. And continuing on here, very quickly, you could obviously, like I've been saying, see that cold front continuing to just spark a bunch of showers and thunderstorms. Actually, down here would be the dry line doing it. But here in just a moment, you'll see that dry line and cold front together. And back here, you could see that spin, these storms spinning, and that's where that low pressure is. Again, it was very, very close to where these storms went off, so there was a lot of lift in the atmosphere. And you can clearly see that cold front and dry line mixing together as these showers and bubble up. And again, you can see a whole bunch of showers developing on the backside as well. Wouldn't surprise me if some of this was snow in the higher elevations out here. This I don't think this shows any winter reflectivity, so it would show like blue or white for snow. But you can clearly see as the system ejected into the plains, it really got stronger, especially where that low was and where that dry line and cold front mixed there in southwestern Oklahoma and the Texas Panhandle. And in the next click or two, you'll really see those storms bubbling up, and bam, there it is. From the southern Kansas and Oklahoma border all the way down to northwest Texas, all of these storms would eventually be severe, and very quickly, that was unfortunately indeed the case. As you could clearly tell how much instability was in the air by how quickly this started moving. And these were unfortunately very quick movers, and the supercell that caused a whole bunch of trouble in southwestern Oklahoma was this storm right here. I accidentally made a 6, that was an oopsies. This storm right here was a supercell. And another thing I want to mention is we were expecting more isolated supercellular thunderstorms. But here you can pretty clearly see that was not the case. And that was because the cold front and the way the main pressure ejected, which is right here, jet stream winds did more of this, which gives it a more linear structure or a line. And that's what we can clearly see right here is more of a line of storms. And yeah, they did start out a little isolated at first, but it very quickly kind of got ruined as they marched east. And a big contributor of that was likely how close the low pressure system was as well, and where it ejected specifically. Let's go ahead and continue this here. And again, like look at Texas right here. That is a very thin line. You will not usually get any tornadoes out of that. But up here in Oklahoma, some thicker storm structure. Sorry. And you continue to see where that low is. That cold front really pressed up against these storms as well. And that's also what gave it that stretchy look and that linear storm motion. And going into central Oklahoma and Oklahoma City, let's go ahead and go to the tornado archive here in just a moment. But something I very want to clearly show you is tornadoes occurred only down here for a bit. And then there was like a noticeable void as these storms ended up merging together into this line. So it became very disorganized. But as they continued their march eastward, notice what happens here. The low pressure now pretty much over here, and the cold front really presses on to these storms. But look at the bow structure. You have a bow here, and eventually you'll have one developing up here. But what's happening is that low-level jet is really starting to strengthen, and you have damaging winds not only in this entire thing, but you have tornadoes ongoing here and up here in the eastern Oklahoma City metro area. And luckily, these tornadoes were weak and brief, but it does show you how quickly things can ramp up because they went from disorganized messes throughout Oklahoma City, and then as they exit downtown Oklahoma City, they suddenly start to wrap back up into a tornadic mess, and you can see where that inflow would be going into here and here. And there was another tornado up here and up near Tulsa. There was a couple, and this is when things started to get pretty bad once again. And as they continued their march east, some showers around that low pressure system began to bubble up behind the main wave. And again, scooching up a little bit, you can really see that bow structure once again. You can see the inflow notches going inwards. And eventually, all these storms kind of fell apart as they continued their march east, but they did continue producing a few tornadoes out here in Missouri, eastern Oklahoma, and Arkansas. They continued to stay tornadic, but they kind of fell apart a little bit. But unfortunately, let's go back up a little bit here because I do want to show you. They came more outflow dominant for a bit until they reorganized, but roughly about here in these storms is when they really started to ramp up with the damaging winds and scooting up by about, let's do one. Yeah, that should do. In this specific little part of the storm, this embedded cell started producing winds 70 to even 80 miles per hour, and that created some damaging winds for sure. But as this continued, it eventually did fall apart quite a bit off there. But what I find really interesting is the low pressure system that's about right here. It really dug in and embedded itself in the atmosphere, and you can see that hurricane-like effect to it. And here's that main low just northeast of Tulsa. You can see that hurricane, almost eye shape, as those rain clouds and leftover moisture from the collapsing storms wrap around the main low. This is what pretty much the remnants of the event. And then here's the main low, just kind of wrapping whatever moisture is left around it, and the dying remnants of the original storms. And you can and that going gets on out of here, but man, you can really see that almost hurricane-like effect. Here's the main low, and then you have the storms and showers wrapping around it. And this is really actually a good detail. I want to go over this real quick. This is how hurricanes would generally look. You have these cells building in on this right side, and that's where you usually get your tornadoes. And then in the eye wall, you would get your most damaging winds, as that's where the low pressure sits. So, man, you get this really good detail in that radar imagery here. That's what you would usually see in really strong hurricanes. And then eventually it does die out, but you can still see that hurricane effect. And there was a couple isolated showers down here in central and southern Oklahoma, kind of bubbled up behind the wall, just like the wall. And going into tornadoarchive.com, here's where that first initial supercell was. You can clearly see a couple mostly EFUs or EF unknown. And then kind of out here in eastern Oklahoma City, you can see where I pointed out that bow out there and even down here. And I want to go over, obviously, these tornadoes, starting with the first of the day, several miles northwest of Lawton. The first tornado occurred multiple miles northwest of Lawton. This tornado was rated an EFU because it did not cause any damage and was really brief, tracking less than 0.1 of a mile. This tornado didn't last very long at all. Moving northeast, the supercell continued to strengthen, creating possibly multiple brief but not recorded tornadoes as the mesocyclone became more shrouded in rain. A few miles northeast from the original tornado, a pair of EF1s would touch the ground. The first one initially wandered aimlessly into Saddle Mountain Cemetery, where it would destroy a mobile home before becoming rain route and dissipating somewhere to the southeast. The next EF1 of the pair began a mile or two northeast as the mesocyclone recycled and produced a separate rotation. Unlike its predecessor, this tornado traveled northeast and crossed highways 58 and 19, where it would tear down power poles and cause significant roof damage to a home, stripping the roof and moving off to the northeast, where it would finally die. So that is these three tornadoes, and the supercell kept tracking this direction. Moving on to the next three tornadoes before the storms would all merge. Specifically, the only strong tornado of the event and the only strong tornado of Oklahoma. The first and only significant tornado of this one occurred just miles to the northeast, undergoing a messy merger with a different cell to the southwest. And this merger allowed the mesocyclone to spin faster. And these mergers can be really dangerous, actually, because of that reason. Let's take an ice skater, for example. An ice skater. Let's say he or she is spinning around and she's going tighter, tighter, she's going faster, and you take your kinetic energy, you grab her arm or something, or his arm, and you wrap it around him or her as well, and you transfer all that kinetic energy to them, and you can create an even faster motion. That's essentially what happens with a mesocyclone undergoing a merger. And this tornado, the only strong tornado of the night, was south of Anadarko. The mesocyclone produced this EF2, starting just west of East 1360 Road. Traveling northeast, the tornado would damage a hangar at Anadarko Airport, but the most significant damage would occur further east, where a home would lose its roof. Despite missing downtown from the south, the tornado still caused widespread damage, especially to homes in southern Anadarko. And it would eventually produce yet again another EFU. This one a little longer, but happened in a field where no damage was observed, so it was given an EFU rating. It was most likely an EF0, and actually there was another one, this one being very, very brief. It's kind of touched down, tickled the ground, and went back up, and that was likely during another merger with the rest of the line. And again, to the northeast, there was this noticeable void here of no tornadoes between Chickasha and Oklahoma City. But you'll also see storm activity began to ramp back up here in eastern Oklahoma City with multiple EF zeros. Starting with I believe the first of them was this one east of Hera. Again, these storms, they would begin to reorganize into a bow segment as they exited Oklahoma City. Near Hera, just east of OKC Metro, just like mentioned before, the bow produced a strong area of rotation to the north, where the first tornado of the second round started. This new tornado caused mostly weak tree damage, but went on to create roof damage to a mobile home near Northeast 63rd Street. Further south, a separate bow segment produced these two tornadoes. This new bow started to increase in strength. Damaging winds as high as 80 miles per hour were recorded in the main line. However, the tornadoes to the north between the towns of Johnson and Dale were ongoing. The tornado that was first produced to the north-northwest, where inflow was feeding into the storm, this new tornado produced EF0 damage and mostly blew over some trees and damaged a barn in western Dale. After this initial and weak rotation faded, a new one further east began to take the show, producing another EF0. This one crossed I-44 like its predecessor before it. This tornado got real close to downtown Johnson. Luckily, it did not, and the rotation weakened beforehand. Instead, the tornado passed over multiple trees and damaged a home. From what I understand, damaged that home with a tree. It kind of knocked over or a tree or multiple branches, and it landed on the roof, causing some very light roof damage. And retreating back up to the north, there was another EF0 here, and from this original bow segment, it recycled and produced another tornado near Warwick, Oklahoma. It touched down, but despite this tornado being brief and weak, it still produced some damage to a couple homes and trees, mostly trees, like I said before. And eventually, that cell would die, because usually these bow segments, sometimes they won't last very long because how they circulate. Usually parts of the storm will get pushed up into the where the tornadoes would spawn, and they would pretty much recycle the entire area. Up here to the north, multiple tornadoes would touch down in a separate bow segment. One EF1, one EF0, and two EFUs. Couple homes were damaged, mostly trees though, again, with those. And something I want to mention down here with this cell, another bow segment produced this tornado here. It was a little stronger of an EF1, producing some damage to homes and buildings, and again, mostly trees, and knocking over power poles. But I want to talk about this one out here in eastern Oklahoma, pretty close to the Oklahoma-Arkansas border. Here's Fort Smith. And this tornado was almost an EF2 and the strongest in eastern Oklahoma. And this was about the time when these bow segments and lines were falling apart. And this is roughly almost an EF2. Got an EF1 rating at 110 miles per hour. It did strip multiple homes' roofs, causing significant roof damage. Pushed over trees, power lines, or power poles, whatever you want to call it. And this was one of the last tornadoes in eastern Oklahoma. We did have one more from a separate area, and this would eventually go on to produce another tornado in Missouri, along with two more northeast of Joplin. In total, over 20 tornadoes were reported, and you can clearly see where this general line of storms down here from northwest of Lawton, Oklahoma, all the way up to western Springfield and northeast of Joplin, Missouri. Very clear path. This was likely actually the same cell the entire time that stayed more embedded in the storms in the line rather than becoming part of one solid line. And that's likely what produced all these tornadoes, because you can clearly see here, and eventually it may have shifted north. I mean, this was a very interesting event, and with the ice storms later on, I'm gonna almost 2 inches of ice, maybe more in some areas, multiple inches of snow across Oklahoma, Kansas, and even Texas. But the most affected area was unfortunately central Oklahoma and northern Texas. Where a lot of that ice and snow accumulated, and unfortunately there were deaths reported. Some possibly, possibly could have got real cold, died of hypothermia, because millions of people were left without power, and a lot of people died on the roads due to car accidents. And that does bring me up to my next subject. You should never, ever drive a car on a road that has even a glaze, maybe not glaze of ice, but you should never drive a car on a road with more than a glaze of ice. It can be very, very dangerous, especially on the elevated bridges. You can lose your life very easily. Even if you're a really good driver, you can get very, very harmed or even kill yourself by accident because you can't see ice at all on those roads. Anyways, my next video, I'm going to give you guys a little kind of sneak peek in a way here. My next video, hopefully coming out in a few days after this. I'm expecting around October 12th to the 15th, somewhere in that time frame. It's going to be about the Enderlin, North Dakota EF5, the new latest EF5, and actually the first EF, again, EF5, not F5, EF5 in North Dakota, but their first overall maxed rating since 1957. But anyways, I hope you guys enjoyed this video. Consider following, liking, subscribing wherever social media you watch this on. And I'll talk to you guys again another time.